హలో హాయ్ అందరికీ గుడ్ మార్నింగ్. సో ఈ సంవత్సరంలో ఇది నా మొదటి వీడియో. సో మీ అందరికీ ముందుగా నూతన సంవత్సర శుభాకాంక్షలు. ఐ విషింగ్ యూ ఏ వెరీ హ్యాపీ న్యూ ఇయర్. సో ఈ వీడియోలో మనం ఎవరైతే జేఈ మెయిన్స్ రాయడానికి సిద్ధంగా ఉన్నారో సో వాళ్ళ కోసం ప్రీవియస్ జేఈ 2020 సెప్టెంబర్ సిరీస్లో ఆల్ షిఫ్ట్స్లో చాప్టర్ వైజ్గా ఏమేమి క్వశ్చన్లు అడిగారో నేను చేయడానికి సిద్ధంగా ఉన్నాను. సో దానిలో భాగంగా ఫస్ట్ వీఆర్ లెర్నింగ్ అబౌట్ ది మెజర్మెంట్ చాప్టర్. సో దట్ ఈస్ జనరల్ ఫిజిక్స్. ఇన్ దట్ వీఆర్ లెర్నింగ్ ద ఎర్రర్ అనాలిసిస్, డైమెన్షనల్ ఫార్ములాస్ and different types of experimental skills. Okay, so in September 1st to September 6th there are so many questions are asking from the chapter measurements. So now in this video I want to explain all these questions. So please follow my channel and subscribe my channel and share to your friends. So let us start our topic. Right, so measurement Jee Main 2020, so which is September 2020. So the question number 1, which is if speed v, area a and force F are chooses as fundamental units, then the dimensional formula of Young's modulus will be. The dimensional formula of Young's modulus. So now let us find the dimensional formula of Young's modulus. There are 4 options are there: A, B, C and D. So the Young's modulus is denoted by the letter Y. Is here we can write that is directly proportional to the which was given that speed, area and force. So we have to take in this order. So that is force and Y is proportional area and Y it is proportional speed. So Y it is the Young's modulus. From these three we can write that the Young's modulus is related to the force, area and speed. It is directly proportional to the F power x and A power y and V power z. So x, y, z are the dimensions of the factors. Okay. So the Young's modulus, the basic formula, it is the Young's modulus y, it is equal F L by A E. F L by A E. E it is also a elongation. It is the length and this is also length will be cancelled out. So F it is the dimension formula for F it is ML T minus 2 and area it is the L2. And then you can write that M L minus 1 T minus 2. So this is the dimensional formula of Young's modulus. Hence we can write that M L minus 1 T minus 2. It is equal to F. What is F here? That is the force. F it is nothing but force. They can be given to us. It is force. It is nothing but M. F is equal to MA L T minus 2 whole power x into area. What is area here? Length into breadth. It is L into L. L2 power y into speed. Speed it is the L T minus 1 whole power z. So now we are comparing the powers on both sides. So here m power 1 is there. So here m power x, L power. So bases are equal, powers will be added. So L power x plus L power 2y. Right? L power z plus z. And t power minus 2x, here minus z. So here in left side m power 1, L power minus 1, t power minus 2. So by comparing the components powers of the on both sides, so x is equal to 1 here. So this is the value of x. So m power x is equal to m power 1. So here m power 1 is equal to m power x. Therefore x is equal to 1. So now let us coming to the second factor, that is L. So x plus 2y plus z it is equal to minus 1. X plus 2y plus z is equal to minus 1. So where is x? It is equal to 1. So therefore 2y plus z, it is equal, what is x here? X, it is equal to 1 minus 1 minus 1. So 2y plus z, it is equal to minus 2. Just keep this value. And now coming to the third one, that is minus 2x minus z, it is equal to minus 2, t power minus 2 here. So minus 2 into x, it is the 1, minus z, it is equal to minus 2, where this minus 2 will be, goes to right side, then minus z is equal minus 2 plus 2, it is equal 0, z is equal 0, the z value, it is the 0. So here the z value should be substituted here, 2y plus 0, it is equal to minus 2, y is equal to minus 2 by 2, it is equal to minus 1. So where y it is equal, so here we can write that x is equal to 1 here, and y it is equal to minus 1, and z is equal to 0. So just you have to put these values in this value, where y it is equal to f power, what is the x, it is 1, and a power y it is equal to minus 1, and v power z is equal to 0. F a minus 1 v0, f a minus 1 v0, b, it is the right answer. B, it is the right answer. Okay. So now let us see the second problem. Now the second problem, which was asked in September 2 shift 2. Previous question, September 1 shift 1. Okay. So this is the question 2, September 2 shift 2. Okay. Shift 2. Right. If momentum P, area A and time T are taken to be fundamental quantities, then the dimensional formula for energy is. So here there are 4 options are there. Let us find the same pattern which we have discussed in previous question. So that is, the energy is here, the related to the energy is related to momentum, area and time. So this is not pressure, this is not power. Only this is momentum. Okay, keep this word. So energy is directly proportional to the, it is related to the P power x, A power y, T power z. So PAT, right? So therefore energy, it is the, so the dimensional formula of energy E is equal to whatever the energy it is, mgh, m it is the m, g it is acceleration due to gravity, L t minus 2, h it is the height, that is L. Then you can write that m L2 t minus 2, right? So therefore m L2 t minus 2, it is equal P power x. P, it is the momentum. So momentum, it is mass into velocity. You can write that mass into velocity, it is Lt minus 1 whole power x into area, length into breadth, that is L into L, L2 power y, and time T power z. Okay, clear. Now let us see. So the power should be written as m L2 t minus 2, it is equal to m power x. So all the x terms are cleared here. L to the power x plus 2y plus 2y. So bases are equal, power should be added. And then t power minus x plus z. Right, now comparing on both sides. So here x it is equal to 1 and y it is equal, so here x plus 2y, L power x plus 2y, L power 2. So it is equal to, so already know the x value, 2y plus 1 it is equal, 2y it is equal, 2 minus 1, y it is equal, so 1 by 2, y it is equal 1 by 2. Okay, and similarly, so minus x plus z is equal to minus 2. Minus x, it is equal to minus 1 plus z, it is equal to minus 2. Z is equal to minus 2 plus 1, it is equal to minus 1. Minus 1. So this is the Z value. Now clear, we can write here from this equation. How we can write that? Energy it is equal to P power X. X it is the 1. A power Y. Y it is equal to 1 by 2. And Z power minus 1. Z it is equal to, so Z is equal to minus 1 and T power minus 1. So here you can check. So P A 1 by 2 T minus 1. A 1 by 2 T minus 1. Okay. So this is the answer. I have to write. Very easy. Now let us see the third question. So which was asked in September 3rd, shift 2. So amount of solar energy received on the Earth's surface per unit area per unit time is defined as the solar constant. So solar constant is defined by the amount of solar energy received on the Earth's surface per unit area per unit time. Okay. So then now dimension formula of solar constant. Okay. Right. So what is the solar constant here? Solar constant, it is equal amount of solar energy received. So solar energy received per unit area and unit time. Solar energy per unit area. So area into unit time. Unit time. So this is the solar constant. Now we can write that energy and area and time. So energy it is equal to M into L to T minus 2. mgh. And then area L into L, L2 and time T. So L2, L2 gets cancelled. It is M L0 where it is T minus 3. This is the solar constant. Very simple. Solar constant ML0 T minus 3. So what is that? ML0 T minus 3. That is option B is the right answer. ML0 T minus 3. Very simple. Just about the solar constant, it is nothing but amount of solar energy received on the surface per unit area and per unit time. That is the basic word you have to remember here. Right. Now the next question, that is fourth question, which was asked September 4, shift 1. Dimensional formula for thermal conductivity is, so here K denotes the temperature. So here there are 4 options are given that. So the thermal conductivity, it is the rate of heat generates dq by dt, it is equal K into A into dt by dx. Therefore K it is equal thermal conductivity. You can write that dq into dx, this one, by area into dt into dt. Right? So dq it is the energy, heat energy, that is joule, into dx it is the meter, that is the distance, by area it is the distance into length into breadth, it is meter into meter, meter square, into dt it is the time, it is second, into dt, capital T it is the here temperature, which is in Kelvin. Now let us turn, joule should be written in another units. So what is the joule here? So work done it is equal F into S. Work done is the F into S, force into S, it is in joules. W it is in joule. So therefore joule it is equal, force it is equal, mass into acceleration into S. So mass into acceleration it is equal velocity by time into displacement. It is velocity it is equal mass into displacement by, it is meaning that S by T into T square into S. Mass into displacement square by time square. It is mass it is kilograms, displacement square it is meter square, by T square it is second square. Okay, so now joule should be written in terms of kilogram meter square second square. You can simply write that. So joule should be kilogram, right, meter square by what is second square into meter. So this one whole divided by what is that, meter square into second into Kelvin. So just to simplify here, how we can write that? So this second square should be downwards. It is meter square gets cancelled out. Okay, right, here there are meter and here kilogram into meter by second square into second cube into Kelvin. So this can be written as kilogram, it is the mass, units of mass, and meter is the units of length, and the second it is the units of time T3, and Kelvin is the temperature. Okay, Kelvin should be written as K in terms of K. So therefore it should be written as M L T minus 3 K minus 1. So this is the dimensional formula for the K, where M L T minus 3 K minus 1, where M L T minus 3 K minus 1. So the option C is the right answer here. Clear? Very simple. Just you should, the simple logic here, the joule should be converted like this. Okay, kilogram meter square per second square. Then you can get the answer ml T minus 3 K minus 1. So this is the thermal conductivity, which is K. Okay, thermal conductivity. This is the fifth question which was asked in September 4, shift 2. A quantity x is given by x is equal IF v square by W L power 4. This is the equation. So whereas I is momentum of inertia, F is force, V is velocity, W is work, and L is length respectively. The dimension formula x is same as that of, as mentioned here, Planck constant, force constant, energy density, and viscosity, quotient of viscosity. సో ముందు మనం ఈ ఈక్వేషన్ యొక్క డిమెన్షన్ ఫార్ములా ఫైండ్ చేయాలి. వచ్చిన డిమెన్షన్ ఫార్ములా ఇందులో దేనికి సూట్ అవుతుందో చెప్పాలి, రైట్? సో ఫస్ట్ మనకి ఇవి తెలిసి ఉండాలి, ప్లాంక్స్ కాన్స్టెంట్కి, ఫోర్స్ కాన్స్టెంట్కి, ఎనర్జీ డెన్సిటీకి, కోషంట్ ఆఫ్ విస్కసిటీకి. సో సింపుల్గా చూద్దాం ఒకసారి. సో ప్లాంక్ కాన్స్టెంట్ E ఈజ్ ఈక్వల్ హెచ్ ని, హెచ్ ఈజ్ ఈక్వల్ E బై న్యూ, న్యూ ఈజ్ ఈక్వల్ టు 1 బై టీ, ఇట్ ఈజ్ ఈక్వల్ ET, రైట్? So E is equal to M L2 T minus 2 into T. So it is equal to ML2 T minus 1. So here Planck constant ML2 T minus 1. Right? So coming to the force constant. So this is one. The force constant. What is force constant? K. K it is equal to F by X. F is equal to Kx. K is equal to F by X. So where force it is M L T minus 2 by X, it is the length or distance, here it is L. So here M T minus 2. So here force constant M T minus 2. And coming to the energy density. So energy density, it is equal to energy per volume. Energy per volume. Right, it is equal to energy, already read that, ml2 t minus 2, ml2 t minus 2 by density, energy per unit density, as here unit density is equal mass by volume, mass per volume. Here mm gets cancelled, volume it is L cube. So here m L2 t minus 2 L cube L minus 3. It is equal to m L minus 1 t minus 2. Here m L minus 1 t minus 2. That is the energy density. Now the last one, it is, what is that? Quotient of viscosity. Neta is equal to F by A into dV by dx. A into dV by dx. Where F it is the m L t minus 2. A it is the L square. And dV by dx, velocity by length. L t minus 1 by L. So it is into t minus 1. Okay. So L and L gets cancelled. Here m L minus 1 t minus 1. M L minus 1 t minus 1. Okay. So this is the here the viscosity m L minus 1 t minus 1. Right. So these are the dimensional formulas for all the constants. So at first you have to write this. Okay. Right. So now let us see from the given data. So whereas the x it is equal I f v square by w v L power 4. L power 4. So I it is the momentum of inertia. Momentum of inertia, it is nothing but I is equal to mr square. It is m into r square, it is equal to L2. F it is equal ml t minus 2. V square it is equal Lt minus 1 whole square by W, it is work, it is equal to ml2 t minus 2 into L to the power 4. Okay. So here this can be written as L square t minus 2. L square t minus 2 because of V square already we can. So this square and this square, it is L power 4 and L power 4 gets cancelled. This m and m will be cancelled. Okay. So here L is there. This L and this square will be cancelled. This t minus 2 will be cancelled. Okay. Just you have to write, there is m. This L is L minus 1 and here t minus 2. So this is the dimensional formula for x, where it is, which is equal to the ml minus 1 t minus 2. ml minus 1 t minus 2. So this is the energy density. It is equal to energy density. Very important question and very easy question. Okay. This is September 4, shift 2. Right, this is the question which was asked in September 5, shift 1. Okay, a physical quantity Z depends on a, B, C and D as Z is equal to a square b power 2 by 3 under root of C d cube. The percentage of errors in the measurement of A, B, C and D is 2%, 1.5%, 4%, 2.5% respectively. The percentage error in Z is. So now we have to find the percentage error. How we can find the percentage error? The video was already done by me. So I will be providing our iCards. So please check once. Okay. So the equation it is Z is equal to a square b power 2 by 3 under root of C d cube. So here percentage error in Z is equal to percentage error in A. Percentage error in A. How much percentage here? So 2% of error in A. In A, so that is A, and plus 2 by 3% error in B. 2 by 3% error in B, and plus how much? Under root it is nothing but 1 by 2. 1 by 2% error in C, and plus here, what is that here? So H, so here d cube, it is 3% error in D. Okay, right, 2.3, 1 by 2, and how much here? Square nothing but, so this is the method. And now we have to find 2% of, so here the percentage error in Z, it is delta Z by Z here. 2% in percentage error, 2% into 2 into delta A by A plus 2 by 3 into delta B by B plus 1 by 2 into delta C by C plus 3% into delta D by D. Okay, so here this 2 can be this square, A square, this 2 will be comes as multiplication. This 2 by 3 here, 2 by 3, and C power 1 by 2 as under root. So 1 by 2 delta C by C. This cube, so whenever denomination under root there will be powers, so we cannot add the root value, then 3 into D. So that is the pattern. So delta A by A, already this is the percentage error in the A, which is given by us. The percentage errors A, it is the 2%. So 2 into 2 and plus 2 by 3 into percentage error in B, it is 1.5, and plus 1 by 2 into delta C by C, that is the 4, and plus 3 into 2.5. Okay, so here the cancellation, 2 into 2 2s are 4, and plus 2 into 1.5, that is 3, 3 into 3 gets cancelled, it is 1, and plus of 2 2s are, and plus of 7.5, 3 into 2.5, that is 7.5, 4 plus 1 5, 7, 7.5, that is 14.5. This is the percentage error in the Z, delta Z by Z, it is the 14.5. So whereas option C is the right answer, 14.5. Okay, so this is the basic method to remember the percentage error. మీకు అర్థం కాకపోతే పర్సంటేజ్ ఎర్రర్ ఎలా ఫైండ్ చేయాలనేది నేను ఈ వీడియోలో ఐకార్డ్స్లో ఇస్తాను, ఒకసారి చెక్ చేసుకోండి. Right, this is the another question, so which was asked in September 5, shift 2. The quantities x is equal to 1 by under root of mu naught epsilon, y it is equal to E by P, and z is equal to L by CR. Defined as C is capacitance, R is resistance, L is the length, E is electric field, B is magnetic field, where mu is permittivity of the free space, epsilon naught is the permeability of the free space. Then, so the options are x, y, z have the same dimensional formula, only x and y have the same dimensional formula, only y, z have the dimensional formula, only x and z have the same dimensional formula. Okay, so x dimensional formula find చేయాలి, y కి dimensional formula find చేయాలి, z కి కూడా dimensional formula find చేసి ఈ 4 ఆప్షన్లో ఏది సూటబుల్ గా ఉంటుందో చెప్పాలి. 3 ఈక్వల్ గా ఉన్నాయా, ఓన్లీ x y ఈక్వల్ గా ఉన్నాయా, ఓన్లీ y z నా, ఓన్లీ z x నా. ఓకే, సో లెట్ us see. So x it is equal 1 by root under root of mu naught epsilon naught. This is the speed of the light. So this is the speed of the light. So simply you can write that the speed of the light v it is equal, what is that here, lt minus 1. So this is the speed where it is lt minus 1. The dimensional formula of the x it is lt minus 1. Coming to the y. So y it is equal to under root, y it is equal to E by B. So this is also speed of the electromagnetic wave. Speed of the electromagnetic wave. So simple you can remember electromagnetic wave, right? So that is the speed also we can write in as, so lt minus 1. Okay, so x and y. So now coming to the z value. So z it is equal to L by CR or RC. So one thing you have to remember, 1 by RC or 1 by CR it is equal given to us time taken. So this is the time where simply you can write that, therefore z is equal L by T. So T for time, 1 by CR it is equal, 1 by RC is equal time. So can LT minus 1. So therefore Z is equal to LT minus 1. Okay, so just you have to see, so this is Y and this is X. X, Y, Z, LT minus 1, LT minus 1, LT minus 1. So both the A, B, C, it is X, Y, Z have the same dimensional formula. So very easy, note it. This is the question which was asked in September 6, shift 1. The density of solid metal sphere is defined by measuring its mass and diameter. The maximum error in the density of the sphere is x by 100%. So if the relative error in measuring the mass and diameter are 6% and 1.5% respectively, the value of x it is equal. So let us find the value of x here. So at first you have to write which are the given values. So given that, so this is 6% is the relative error in measuring the mass. Relative error in measuring mass, in mass. So that is delta m by m, it is equal. So that is the relative error, which is delta m by m into 100. So that is the, what is that here, 6%. And similarly measuring the diameter, so relative error in measuring diameter, so it is delta d by d into 100 is equal how much, 1.5%. These are the values you have to keep it. And now then you can find the density of the solid sphere. Density of the solid sphere, density rho, it is equal to mass by volume. Mass by volume. So rho it is equal to mass by volume, it is nothing but 4 by 3 pi r cube. So r it is the radius here. So they given to us, what is that, diameter. So r it is equal diameter by 2. Radius it is equal diameter by 2. So just simply keep your mind. So m by 4 by 3 pi into r by, it is d by 2. D by 2 whole cube. It is equal m by 4 by 3 pi into d cube by 8. So 2 cube it is 8. 4 2s are, okay, 3 2s are 6. It is 6 m by, what is that, pi into d cube. It is equal 6m by 5, 6 by 5 m d power minus 3. So d should be as d power minus 3. It is the rho. The relation of rho, it is directly proportional to the mass and to the d power minus 3. So this is the final relation. From this you can write that, so you can write from this equation where delta rho by rho into 100, it is equal delta m by m into 100 and plus 3 into delta d by d here. Already delta m by m into 100, it is 6%. Delta d by d, it is equal 1.5%. 6 plus 3 into 1.5, it is equal 4.5 plus 6, it is 10.5%. What is that? Delta rho by rho into 100. So this is the maximum relative error, percentage error in the density. So this can be equal to the x by 100%. It should be 10.5%. It is equal x by 100%. Okay. Therefore, 1050 by 100, it is equal to x by 100. Where x it is equal to 1050. Right? So this is the value which are in option A. Okay. So dear students, these are all the models which are asked in September session 2020. So you should focus on these type of models. Previous knowledge is very important. You should focus on it. I wishing you all the best. If you like this video, please like us and subscribe our channel. Thank you.